Space is a noisy place, filled with a cacophony of sounds that we can't hear. We just can't hear it with our human ears, not with our ears anyway, but with the right equipment, we can capture these sounds. NASA is on a fascinating mission to listen to the Sun, our closest star. It's using special tools and advanced technology to pick up radio waves emitted by the Sun. These waves are invisible to our eyes, but are filled with valuable information. Why do we care about what the Sun is saying? What makes these radio waves so important? The Sun is a massive ball of burning gas, a fiery giant in our solar system. It constantly releases energy in many forms, including radio waves that travel through space. These radio waves can tell us a lot about what's happening inside the Sun, revealing its secrets. Understanding the Sun is crucial because it has a direct impact on us here on Earth. The Sun's energy drives our weather patterns and influences climate change. It also affects our technology, causing disruptions to satellites and power grids. By studying the Sun's radio waves, we can learn to predict and prepare for these solar impacts. This mission is like a doctor listening to your heartbeat, monitoring the Sun's health. It helps us understand the Sun's health and how it might affect us, preparing us for space-related challenges. With this knowledge, scientists can better analyze data and prepare for future solar events, ensuring our safety and technological stability. Imagine listening to the radio. You hear music, news, and talk shows. These are all carried by radio waves. The Sun also emits radio waves, but they don't sound like anything you'd hear on your radio. Instead, scientists convert these waves into spectrograms. These are like visual representations of sound, allowing us to see the invisible. These spectrograms reveal bursts, spikes, and other patterns that are otherwise hidden. Each pattern tells us something about the activity on the Sun, like a secret code waiting to be deciphered. For example, a sudden burst of radio waves might indicate a solar flare, a powerful eruption of energy. These solar flares are like explosions on the Sun's surface, releasing massive amounts of energy. They release enormous amounts of energy which can travel through space and reach Earth. This energy can disrupt our communications and GPS systems, causing significant issues. By studying the Sun's radio waves, we can track these flares and other solar events in real time. This helps us understand how the Sun impacts our planet, from the weather to our technology. Scientists are constantly analyzing this data to predict solar activity and protect our technology. The Sun's influence on Earth is profound, and by listening to its radio waves, we gain valuable insights. These insights help us prepare for and mitigate the effects of solar activity on our daily lives. To listen to the Sun, NASA uses special antennas and highly sensitive receivers. These instruments are meticulously designed to pick up faint radio waves from the vast expanse of space, allowing us to understand more about our universe. One remarkable example of this technology is the Parker Solar Probe. This groundbreaking spacecraft is currently orbiting closer to the Sun than any mission has ever dared to venture before. The Parker Solar Probe is equipped with state-of-the-art instruments specifically designed to measure solar radio waves with unprecedented accuracy. In addition to measuring radio waves, it also carries a suite of other sensors to study the Sun's magnetic field and the particles emitted by the Sun, providing a comprehensive understanding of solar phenomena. Another incredible tool in our arsenal is the Daniel K. Inouye Solar Telescope, located in Hawaii. It's renowned as the world's most powerful solar telescope. This telescope can observe the Sun in incredible detail, capturing images and data that were previously unimaginable. These advanced tools and technologies allow scientists to study the Sun's radio waves and other solar activities like never before, opening new frontiers in solar research. Think of it like having a powerful new telescope to observe the stars, but specifically designed to unlock the mysteries of our very own star, the Sun. The Sun is constantly releasing a stream of charged particles called the solar wind. This wind travels through space and can interact with Earth's magnetic field. This interaction can create beautiful auroras, also known as the northern and southern lights. But strong solar winds can also cause problems. They can disrupt satellites, power grids, and even astronauts in space. Scientists call this space weather. It's like weather on Earth, but it happens in space. By studying solar radio waves, we can better understand and predict space weather. This is crucial for protecting our technology and astronauts. Section 5. Protecting our planet. Imagine a future where we can predict space weather just like we forecast the weather on Earth. This is one of the goals of studying solar radio waves. With enough information, we could prepare for solar storms, we could protect our power grids from blackouts and safeguard our satellites from damage. We could even warn astronauts to take cover during a solar radiation event. This knowledge would help us protect our planet and our way of life. Section 6. Beyond the forecast. Studying the sun's radio waves is not just about predicting space weather, it's also about unraveling the mysteries of the sun itself. For example, scientists want to understand why the sun's outer atmosphere, called the corona, is so much hotter than its surface. This is a puzzle that has baffled scientists for decades. By analyzing radio waves from the corona, we might find answers. This knowledge could help us understand other stars in the universe. Section 7. A deeper dive into the solar system. The sun is not the only object in our solar system that emits radio waves. Other planets like Jupiter also have their own magnetic fields and radio emissions. By studying these emissions, we can learn about the internal structure and atmospheres of these planets. It's like using radio waves to see beneath the clouds of another world. This knowledge helps us understand how planets form and evolve. It also provides clues about the potential for life elsewhere in the solar system. Section 8. A universe of waves. Radio waves are just one type of electromagnetic radiation that travels through space. Other types include visible light, X-rays, and gamma rays. Each type of radiation provides a different window into the universe. By studying all forms of electromagnetic radiation, we get a more complete picture of the cosmos. This helps us answer fundamental questions about the universe. How did it begin? What is it made of? Are we alone? The sun's radio waves are just one piece of this cosmic puzzle. By listening carefully, we can unlock the secrets of the sun, the solar system, and the universe beyond.